So hi folks, I'm Keshav Murthy. I'm the Director of R&D for Nickel, for Couchbase. So today I'll be focusing on why there's a need for SQL-like language on a NoSQL database, and what we have done, what its features and all that. Before I started, so since you commented on the aggregation framework in MongoDB, I do want to answer that in context before I go there. So, aggregation pipeline in Mongo was invented so that they have a nested level of one level of aggregation. That data from one level of aggregation can flow into the next level. I mean, you see with both with analytics service and Nickel, we are SQL-like language. Your queries from your derived tables, selects are from, and then you can have a subquery, selects are from. So those things naturally flow from one layer to the other layer. So that whatever you can achieve in the aggregation pipeline, you naturally get this in SQL. Okay. With that answer. So let me start with why NoSQL. So before I start, just so that I can divide my time between different aspects, how many of you have used Couchbase so far? Okay. How many of you use MongoDB or any other NoSQL database so far? How many of you know SQL, any kind of SQL? 95%. That's great. I don't have to deal with basic, very basics. Okay. Like I said, why NoSQL very quickly, and then before you have to bring SQL to NoSQL, you have to bring the data from SQL to NoSQL. We'll talk about the modeling a little bit, and then the query language. Okay. So this is kind of the standard reasons why people who develop enterprise applications go from a SQL-based database into a NoSQL. You want developer agility, you want flexibility of the schema, you want to be able to scale out on commodity hardware, performance, specifically performance when you have large number of users, they need extremely low latency answers for your data. Right? I won't say queries. Complex queries can take seconds. I mean, it's like you saw. But when you're building an application that requires high throughput and low latency at the same time, you choose NoSQL. And last but not the least, availability. You want the applications to be available despite failures. You want any downtime for any part of the data or any part of the application to be as low as possible, because this has an effect on your revenue. Okay, so I won't go in detail about everything except to mention that in the context of query language, flexibility, schema flexibility is important. Right? That's why we chose the JSON data model. So when you have data modeled in JSON, you get the flexibility, data model flexibility for the application. So the knowledge of the model, the maintenance of the model, knowledge of the model shifts from database into the application. The application has to be aware of what is the model that I'm dealing with, and you handle versioning and all that. But you get the advantage of changing the model, or if you're consuming newer data, changing the types in the application rather than waiting for the database DBA to add new columns, or even cannot do it because the changes are incompatible with the previous version. Right? As the business requirements change, you can change your model. You can iterate over your application quite quickly. Okay. So now. Couchbase uses JSON model to store all your data. Right? All your data is, we do have an old form of storing binary data, but for your application development, use JSON data model with Couchbase, whether it's Nickel, TV engine, or the analytics service. It's a JSON data model. So let's look at how we first bring the relational model into JSON and then the query processing over it. Okay. So let's look at a customer object. This customer object has rich structure. It has the basic primary elements: name, date of birth. You could have complex structures for billing, connections, purchases. Each of them can be a complex object. This customer has relationship with other objects. You need to represent relationship with this model, and of course information about their purchases and so forth. There's a customer object. This has to be modeled and stored within your database, right? Can this be modeled in the relational world? Absolutely, right? So you flatten the complex object into multiple relations and represent them as each relation as a table. And to construct the rich object, you join, and when you insert or update, you insert or update to the respective tables as depending on the value you change. You do the value evolution by the standard insert, update, delete, but value evolution is kind of a built-in and easy, but the structure evolution is what is more difficult with the relational model. When you need to alter the table, then you need downtime and agreement with all the parties who are using the table and so forth. That requires application downtime, and downtime is what costs you money, right? That's why the schema flexibility is important. So now let's see how can we migrate the same data from your tables into a JSON object, right? So your columns will be represented as key value pairs, right? So your name is, Jane Smith will be Jane Smith, and date of birth represented as a string here, and you can choose to split them, split the name from Jane Smith, first name and last name and so forth. With Couchbase, your primary key becomes your document key, and this is the document we use in the flowing example. Now you have two different tables with customer and billing, but they have relationships. So instead of now, because you have the data is represented in two different tables, every time you need to construct a customer object, you need to join. Typically in JSON, you store this billing information as a single object, and note that I have not just used it as a billing with a single object. I have made an array, because you would have, each customer could have multiple billing information. You have one-to-n relationship, so each of the objects become each of the rows, each of the entry in the billing table becomes an object within your billing array. Okay, so here we have a customer with two different credit cards, so that each of them becomes two different objects within a single array. If you need to add a new structure, let's say you started out with just the basic information billing, you need to add a connection information. There is no order table, you simply update the JSON document with additional information, so the structure is understood by the application and not enforced by the backend. So finally, your 5-table information in the relational store is represented as a single JSON document. This is the process of denormalization that you typically go through. So the customer object that you have represented as a single object in your application can be represented as a single JSON document. Okay, so this is the different important difference between the relational model and the JSON document model we use in Couchbase.
So what is the document key here? In a regular database we use a primary key, right?
In the regular database you use a primary key, and here you have each, in the Couchbase, each JSON document that you insert will have a unique unique document key. It's unique within that bucket, So in this case, you have the CBL2015. That becomes your essentially your primary key. That's a unique document key that you insert that sits outside of the document. There was a question in the back.
Yeah, so if you have like 200 tables instead of 5,
Yes.
How do you reason about putting the data of 200 tables into one object versus putting the data of 200 tables maybe into 5 objects?
Yeah.
What's the thought process behind that?
Very good question. Just repeat the question. The question is, instead of 5 tables, you have 200 different tables. What's the thinking behind whether to make the 200 tables as a single big object or multiple objects? So our thinking is to denormalize the related information into a single group. Don't artificially make 200 tables into a single universal object. For example, you have customers and orders, right? So you have a customer object, you have orders object. Can you denormalize everything into a customer object and get all the orders for a single customer into a customer object and make it a bloated customer object? Yes. Every time you get a customer object, you want to retrieve all the information, all the orders that a customer has. Depends on the application, maybe not. If not, you have a customer object, then an orders object, and orders object can have a reference to the customer object, and that's why in Nickel from the start we supported joins, because you want to be able to represent things in multiple multiple types of documents, and because just from the access pattern point of view, yes, when a customer logs in or when a customer calls, you want the customer object, but you also have business users who want to find out how much did we sell yesterday, what did we sell yesterday, what are the shipping orders that are due. You want to be able to scan just the orders object as well. So yeah, you can model complex relationships with JSON and Couchbase. So it depends on what works for your application.
So to add more to that question, so how about if you have cross grouping, like you said let's say you're going to partition that in 520 groups or something, which is 200 tables, right? But then you may want to have queries aggregating data from all those groups, right?
Okay. So the question is, if you have data in multiple types, you want to be able to aggregate data with data from 2 different groups. So I'll show you those examples in a moment. So you have multiple groups of objects there, like different tables. Logically, you think of it different tables. So if you want to aggregate data with data from 2 different tables, you first join and then aggregate.
But if you denormalize it, then it means you have a lot of duplicates like all over the place, right?
Yes.
So maybe, back in the day when Peter Chen did the entity relationship modeling, right? Basically there were entities and there were relationships, and there were different relationships. You had strong entities, you had weak entities, right? And that's actually a pretty good way. If you have an entity relationship model, right, you translate to a relational model, then basically it's very simple, because every relationship becomes a new table, right? That is one level to flatten, right? But you can also choose to say, okay, weak entities, for example, are a prime example for something that you want to nest in a strong entity, right? That is kind of, if you just go by the pure kind of entity relationship modeling, right? You already get to a better physical layout in a database that supports nested data than you get in a database that's only flat. And then the next question is, do you do some additional denormalization for specific use cases or specific applications that you want to support with certain performance characteristics?
Or like a classic example, since you brought up order entry. What if the address at the time that you ship the order is not the customer's current address? You actually represent that because you have an order that can have order line items. And the shipping address is part of that order, which is a really big denormalization.
Last question before I move forward.
Maybe I can comment on this question just for a moment. Okay, a lot of this data, one major reason for database theory is because you're trying to take non-tabular data and reduce them in tables. Whereas in Couchbase itself, like you're just dealing with data in a non-tabular manner that it already is. I mean, there's a lot of data out there that's already non-tabular. So instead of taking the time to take non-tabular, turn to tables, and then turn it back, and it's like, in Couchbase, it's already non-tabular. So you select non-tabular, you produce non-tabular.
Well, I mean, data is data, right? You have a choice of your model, right? Because we have a separate talk on just the data modeling itself. That will take some hours. We actually have those talks on YouTube. But you design the model to represent relationships and the structure of the data, and also in a way that it makes it easy and efficient for your processing. Eventually, you don't model data just for modeling. You want to process and get some job done, right? So you have choices based on what you want to achieve. So that's why in Couchbase you can denormalize to the nth extent, or you can keep it as separate entities which you can join. Okay. So these are the high-level differences between the two different models. So in the interest of time, let me get on to the SQL for JSON. Okay. So if you have a database that provides just JSON without a query language, what do you need? How do you access your data, right? You have a key value, get, set, and sophisticated set of APIs which can get you the data. And usually, if you want to do any set operation, right? Give me all the customers from Mountain View, or give me all the orders that are pending. You typically write a program to get the documents and process it, rather than issuing a declarative query and which will get you the results that you want. So eventually, you want to get the job done as efficiently and as effectively as possible. That's the reason to get back to we want all the advantages of distributed database with flexible data model, but you want a query language that works, works, and quacks like query. Right? Here is an example, right? So if I want to find a high value customers with orders more than $10,000, right? If you simply have a set of JSON documents, you have to write a program that fetches each object and finds what is the finds the order value, get the grouping done by customer, do the aggregation yourself, and finally come up with a sorted list. And first of all, you have to write a complex program, debug it, prove it, and then obviously doing this by getting the whole document to the application side is pretty inefficient. Okay? So more and more, even the databases who are recognizing JSON as a type or a model within your data modeling are adding JSON representation to standard SQL database. Microsoft Asterisk DB, which has now become the Couchbase analytics service, we have support for SQL and SQL++. And Couchbase, of course, invented Nickel, and now we are adopting SQL++ to implement and support the rich declarative query language. Right? Declarative easier said than implemented, but declarative means once you have the data, you can pretty much write any kind of query to get the answers that you want. Okay? So now with that, Couchbase Nickel, what is our goal? Our goal is to give developers and enterprises an expressive, powerful, and complete language for querying, transforming, and manipulating JSON data. Right? So what can you do with all this power? Our aim is to help you develop applications, rich applications on it. Right? So the Nickel query language and the query service helps you to develop applications, and the data that these applications use and produce gets transported onto our analytics service, where you can issue queries to get insights. Right? You run the applications with one set of services, and the same data is available for analysis, trend analysis, insights, and so forth. That's the whole structure, right? Speaking of that structure, so you can have multiple nodes with data service, index service, all uniformly deployed service. With our multi-dimensional scaling, you can also have a cluster with few nodes which have just the data services, few nodes with query service, few nodes with index services, and few nodes with analytics service. I just ran out of space to add n number of services here. So this is the structure that you saw from Till and Iggy before. So let's get back to our language itself, right? So what is SQL? Every SQL DML statement takes set of relations as input, and it processes it and gives you back a result set that's another relation, right? That's SQL. So how does Nickel relate to it? We get sets of JSON documents, we process it, and the result is sets of JSON documents, right? So JSON in, JSON out. There are some query processing engines that process JSON but gives you a flat data, but Nickel, JSON in, JSON out. The most simplest form of JSON is a flat relation, but you can get a rich input structure and rich output structure. That's the main aim. Right? In its simplest way, so the Nickel looks and feels like SQL. In addition to the select, join, project operations that SQL provides, Nickel is extended to support the nested objects as well as arrays of objects and so forth. So we introduce two new operations to this select, join project. That's the unnest and nest operations to create and unnest the arrays, right? And we also made JSON as a first class literal. That means at any point you can give an expression, you can also give a JSON object. We have JSON constructors supported everywhere, whether it's projection, values, or predicates. JSON can support everywhere. And we'll talk about this in a moment. So that means each of the key names within the JSON document is looks and feels like a column within the table. But we'll see how we refer to the nested objects and arrays and so forth. Okay, here is an example. Where we are selecting from this set of JSON documents. So in the projection list, customers.id is a standard reference. It's a simple ID column. When you have a nested object, customers.name.last name, name.first name. So we have a dotted reference for your nested object. And then you can do the projection, you can do the aggregation just like you do your SQL. Then in the from clause, you see the first operation, you have orders. So if orders has a complex set of objects, you can unnest to flatten the array objects. Then once you flatten, you can also join the orders with other set of tables or buckets called customers. And so we support both inner join and left outer join right now. So then in the predicate, we are interested in customers in New York. So the predicates, you can have any Boolean expression within your predicate. Then group by clause works like just like the standard SQL group by clause, and same thing with the having followed by order by as well. So this with that with an extension to support the nested objects and arrays, this is Nickel, and SQL++ is derived from SQL. We have a saying that we don't want to change anything in SQL unless it is necessary to support the JSON and complex objects or operations within SQL. And like I mentioned earlier, SQL by nature is composable, so both Nickel and SQL++ are very composable. You can nest them, and the processing is done just like SQL. Okay. In terms of execution, so you have your JSON data loaded, and you need to execute. Ingi showed the example where the queries that are running on the analytics service, they're all parallel. When you have multiple nodes, they're parallel. It's an MPP query engine for analytics. In our case, so we have our when you have your application, you submit your query to your query service over REST API. So REST API is the basic REST over HTTP protocol that we use. On top of it, typically in applications you use our SDK, ODBC or JDBC drivers we have from our partners. So you submit to our query service will parse, analyze, and create a query plan, right? And if we are using any of the index, we send the scan request to our index service, which will return the list of qualified documents and document keys back to the query service. And query service will fetch the, if necessary, it will go to the doc. If the index can cover the whole query, we'll just do the covering index scan. If we require to get to the data, we go to the data service and get back. And once we get the data, we do the any further filtering, joins, pre-aggregation and aggregation, sorting and pagination is done in the query service, and answers are sent back to the client, right? So the language is similar to SQL, and if you are familiar with how the database systems process any query, this is not so dissimilar from that, except each of the layers have been abstracted out and because they are loosely coupled, we can distribute, we can scale out and deploy each of the services in same node or multiple nodes as in whatever is necessary to meet your performance goals, right? Looking at this a little bit more internally, right? From the parse to plan phase to scan, fetch, etc. So the data flows from parse to final projection and pagination seamlessly, and this is essentially a data flow engine. All the stages you saw, these are not blocking calls. As the data is gotten back from the index service, in parallel we are streaming the data from the data service, and the rest of the processing joins and further filtering is going on simultaneously if the query requires those stages. And we also parallelize the access and the processing wherever it's possible. Yeah. So this is prepare phase, run phase, projection phase. So this is to say that we support the prepare once and run multiple times paradigm that people are used to in your application development. Okay, so that's the structure of how we execute the query. So in terms of the language itself, we support the inner join and left outer join. We support correlated and non-correlated subqueries within your statements. Aggregation, all the standard aggregation, min, max, things are supported. In addition, because the underlying data model is JSON, we support for whether it's sum, match, whatever, simple, even for the simple aggregates, you can aggregate in an object. You can construct an object and get the resultant aggregate as an object. And you can construct an array as an object. You can do aggregation over arrays as well. Standard set operators, union, all, intersect, except are supported as well. in Couchbase, since we can get to the data directly using the document ID, sometimes if you, in your application, if you do know the application ID, you don't need to use an index to find out what's the actual document key. We provide you an access, provide a mechanism for you to get to the data directly from the bucket. You need to have relationship based on document keys to do the joins, whether it's the inner join or the left outer join, one way or the other. Either you can start from the child and join to the parent, or you can start from parent and join to the child using our index joins. So we support nest and unnest to flatten and create arrays dynamically within your application. And this is highly composable. You can use join, nest, unnest, left out join, right out join in any combination in your to process your data. Just like in SQL, you can have any combination of inner join, left out join, right out join, full out join. You can have any combination. So that same thing is supported here as well.
How does that affect the optimizer?
I have a separate article on how optimizer works, but I can tell you, give you a quick answer. So in Couchbase optimizer today, we don't reorder the joins. We join from left to right as you have written the query. We don't do the cost-based reordering yet. Right? That's one of the things in our plans within Nickel. Ingi, do you do the join reordering within?
No.
Yeah.
No.
So.
Yeah, but my question is really not so much about join reordering, because joins by definition commute, unless there are some other restrictions. But operators like nest and unnest, they probably don't commute to other operators, right?
Correct. Eventually, when we do the the cost-based reordering, we will be cognizant of what is commutable, what is not.
Okay.
So so providing simple SQL that works like SQL on flat data is is relatively straightforward. But we do have JSON by nature is nested object. You can have objects of arrays of objects of arrays. So we have expressions that operate over these nested objects, arrays of objects, and these expressions themselves can be chained to operate on JSON at any level. Here, for example, the any C in children satisfies c.age greater than 10. It says any value within the array children that satisfies C dot, that means each element within children is an object. That object dot age is greater than 10, right? So Nickel has expressions to operate and filter objects, arrays of objects. So these things can be chained together. For example, within the satisfies clause, you can have any expression so that you can operate on arrays of arrays.
Do you support nested?
Yes.
Like recursive nested?
So you can nest it. You have to nest it explicitly. If you want to find a value within that substructure, you can use an expression called within, and then it will search over it. But if you know the structure is well known, or you want to find a value within a specific level of that nested structure, you can nest an expression within an expression.
But if you don't know the level of
you can use it within. You can say, I want to find this value for this type of field within this. So it will search all the way through.
How about if you extract the structure so that you can and everything, right?
So exactly. Again, a combination of dotted expressions and array expressions get you to wherever you want to. And you can construct a sub-object or arrays of sub-objects, anywhere an expression is used as well. Last but not the least, because the model supports flexible schema, there is no enforcement, there is no constraint on the back end to say, I want these values to be there all the time. Things can go missing. So if you project a value that is missing, you'll get missing value. You can introspect to say where A is missing or A is not missing. Similar to A is null, A is not null. If it is missing, it will be true. If it is not missing, it's false.
But how about if you don't know the name,
That's a good point. So let me make a slight comment here. So in relational schema, the metadata, that means the columns and the types, are very well known ahead of time. So in JSON, when you are developing certain applications, you may not know the actual structure of the data that is coming in. We have, maybe I'll point to separate blocks and information that can help you. But we have language extensions to get and operate on the metadata as well as the data. Right? SQL operates on the data. In here, we have to operate on the metadata as well. So you have to find out, okay, so if you have a key value pair, what is the name, what is the value? If you have a structure, give me all the metadata names. Right? We have rich set of functions and expressions to get you and manipulate and construct metadata portion of JSON as well as the data. Right? That's a big
problem. Because every relational database I'm familiar with represents metadata as data in system tables.
Yes.
So what's?
No, but
I don't see the distinction here, right?
Sure. So in relational tables, it's very easy to, if you have a table object,
Right.
give me all the columns for this table object. And that table object is, that the set of columns for the table is fixed for the table.
Right.
So here, you can't do that. If you have a customer table, give me all the columns for this customer table, customer bucket. I don't know. You have to go through the whole set of documents to find out, oh, one customer object has their hobbies, other customers. It's chaos, right?
Of course, I don't
So-
know.
so- so-
You keep a dictionary, right?
Yeah. So you have, so what I'm saying is the language gives you the ability to query this metadata for each document and manipulate it, construct it. So you have the flexibility to do that. If your document is very flexible and you have.
Well, if we think about SQL like a DSL, like a language, right? So the reason it works is because it has the types, which are the tables, right?
Mm-hmm.
So the problem here is you don't have types. It's kind of like in Python, right? So you can put in a list all sorts of garbage, and then after that you set your head how you deal with the types.
Okay, no, that's correct. It's extreme flexibility, right? With extreme flexibility comes extreme responsibility, or something like that.
The question is like even if you do the metadata first, right? So you may get data later that still has stuff.
Absolutely. That's why what I'm saying is you cannot do the metadata first. You will have to, if you expect an extreme flexibility, you want to handle this extreme flexibility, you will have to introspect each document and be dynamic about it. So I'll point you to a example where we have illustrated how this can, and this is actually a real life example. I'll probably, I'm running out of time, I guess, but I'll tell you that. And I was going to say the gentleman here before. So Evan here is our senior engineer. So he implemented a utility that helps you to understand the structure of your JSON documents very easily. It's called the infer command within. If you hang around after that, I'll show you. In infer to understand the structure, sample data. So both from a user point of view, it is very, very helpful. It also helps you to construct your queries, all the for interactive usage. So we have done some progress in terms of making sure developers understand the structure some structure within this flexible scheme. Okay.
Can you please put that?
Okay, we will provide that links and this information in the meetup. Okay. JSON supports these 6 different types. We support all those types within Nickel, and we added the binary and the missing as a standard data type. The big thing that is missing from the JSON standard data type is the date, time, and date time. So we have, so you'll have to represent that as strings, and we have got large number of functions that will help you to do the comparison, manipulation of datetime functions. That itself is, as anybody who has developed enterprise applications, that's a full-time job to understand and manipulate data. So we have large number of functions well documented within that. It's not just about the select. So we have the full-fledged statements from update, insert, delete, as well as merge. But when you are operating on multiple documents within a single statement, underlying Couchbase infrastructure provides per document atomicity. So you don't have a multi-statement transaction within this NoSQL system. Yeah. So like I said before, these things work pretty straightforward way if you know standard SQL. Okay. Somebody said, there are only 3 things important in query processing: performance, performance, performance. So if you don't have a good good index, your performance will not be so good. So having those our indexes within query service within Nickel is pretty similar to what you have within relational databases. So primary indexes, composite indexes. We also support each of the keys can be any expression. So these expression-based indexes are there in most of the databases as well. So those are called functional indexes or any type of expression. And we also have partial indexes. That means you can create indexes and with a where clause. So that means you create an index. If you have a customer bucket, you say create index blah 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 where location equals New York. So that index will only contain the data that is that has that predicate qualified, and we automatically choose that index if you have the right predicates within your query. Let me show some examples. Okay, so you have your customer object. So you can create a customer index on this customer object with ccinfo dot card number. So we support any keys within any levels of nested object, and you can combine simple keys, nested object keys, expression keys, any combination thereof. What is missing from this? Array index, right? If you have arrays, how do you index arrays, right? Okay. So these are all standard list of all the different combinations, but I don't need to go in there. So let's say you have an array called public likes, right? So then you can create an array saying that I want to index on each of the values within the public likes, right? And then once you have it, remember I said we have expressions to ooh, it's automatic. Expressions to do a predicate on this arrays. So I have any p in public likes satisfies p equals Joe Smith or whatever, right? So you can have that predicate, and it will use this array to find the values. I'll show you that example in a moment. So in summary, right? So if you have a NoSQL system without a declarative query language, to answer any complex question, you'll have to write your programs Instead, the declarative query language will give you a simple way to write the query and get the answers that you want. And you, like I said, both the analytics service and Nickel query service, we work very hard to stay as close to SQL as possible. But obviously for JSON, we have to make those extensions. So everything that you know from SQL applies here as well. Okay. So SQL has select, insert, update, delete, merge. We have the same things. SQL has select, join, project, and subqueries. We have those, as well as nest and unnest. So schema is enforced in Nickel. Schema is understood by the application, and you don't have type mismatch errors because we have rules for how the different types are compared. Pre-written columns in SQL. In Nickel, we have flexible schema. SQL definitely has rich set of SQL data types. We support only the JSON data types along with the conversion functions. SQL is input is set of tuples or relations, output is set of tuples, whereas in Nickel, its input is set of JSON, output is set of JSON. Let me show you the example. Oh, okay, I guess I have to. For example,
Make it bigger.
this is the nice query workbench and the new UI we have in 5.0. So in this case, I have select star from table sample where type equals hotel. Let me show the index that I've created this, for example. I guess people in the back won't see. So this is the index on the public likes. So now I do this query, and when I see the plan, so we have the visual plan here. We have the index scan tool. Let me just show you the plan here. Okay. So I had this any x in public like satisfies x equals dollars whatever spent. So I have the low and the high here. This is the start and the stop keys of the index scan, if you know, and it's using the index called index travel. Okay. So that's the array manipulation within Couchbase. So this is my final slide for sure. Okay. So for more details, we'll post some of the articles and resources on the meetup page. So you can go to query.couchbase.com for getting more information. Our last full release is 4.6.1. We also have 5.0 developer preview already in public. Please download and use all the features. And we also have an interactive tutorial from query.couchbase.com where you can actually play without doing any downloads at all. You can just issue queries to explains just from the browser. And if you do have any questions, please post it on forums. We are very active on forums. We try to answer all the questions. I know I've ran 10 minutes over, but I'll be here answering questions till the last question.
So remember at the first beginning, the full text search was mentioned. Is it covered in the NoSQL language or is the other?
Okay. The question was full text search was mentioned as a service. Is it covered under query language? Full text search is a separate service. It has its own API interface and so forth. So it's a we have very good documentation and even talks on full text search on again Couchbase channel on YouTube. So it's a separate service syntax. But in 5.0 we have this one mechanism to use full text search with nickel, but so full text search is an index, right? Just like our global second index, it's a separate index. So we have one simple level of integration, but we look forward to do more integration together.
Is the SQL plus a superset with nickel, or is it not related?
Sorry, can you please repeat?
The SQL plus.
SQL plus. Okay. The question is SQL plus nickel is integrated? So these had slightly different origin and heritage, but we have done work in a way that at an internal foundational level they are convertible. We are thinking and working on make the integration even at the language and application level. Right now they're different, but we expect things to converge so that you have a single language. Yes.
In some of the queries, see you have keyword N. What END?
Okay. So this end, end is a keyword that says this expression any has ended.
I need it.
Yeah. So you can.
That's ended.
Yeah. So you can within this, let's say it satisfies this expression. If you have arrays of arrays, instead of p, you can start another any blah blah blah. So you will have nested ends. So end is just an expression ender.
Thank you.